So for number 22, we started off by drawing a figure of the capacitors, and we noticed how they're connected in parallel, and then we wrote down the given values for the capacitance of each of them and each of their charges.
Alright, our first step is to find the total initial energy stored in the whole system. To find that, you have to add the initial energy stored in capacitor A to capacitor B. We use these formulas. So for capacitor A, we plug in our givens up here, we get 18 millijoules. We do the same step for capacitor B, we get 9 millijoules. When we add them together, we get 27 millijoules for the whole system.
So, since we know that the system of capacitors is in parallel, we know that the capacitance of the electrostatic equilibrium is the capacitance of A plus the capacitance of B. And if we plug in those values, we get 12 millifarads. Then we know that the total charge across the system is the charge of A plus the charge of B. And if we add those values, we get 24 millicoulombs. In order to find the final energy stored in the system, we can apply the equation Q total squared over 2C equivalent. And when we plug in those values, we get 24 millijoules.
Now that we found the initial energy stored and the final energy stored, we subtracted the two values and we found that the total change in energy stored is 3 millijoules.